for us and early for the Australians, so we appreciate it. For those who haven't been on these in a little while, we have Peter Broley with Primary Sales Australia presenting, Cassie van der Westerhuizen, who's an ag diesel technician, and Brett Asfer, who's a harvester mechanic. And I don't see Peter Newman on, is he? Do you know if he's joining?
He is. He will join.
Okay.
I know he's got an even early morning meeting.
Okay.
So
Peter Newman
we'll
from
give him a break.
Weed Smart and Plan Farm, we hope will be here to chat with us too. And maybe Michael Walsh from the University of Western Australia. So those should be mostly who you hear speaking tonight. And I will hand it over to Peter Broley to go over terminology and tell you what he's going to talk about.
Okay, thanks very much, Emily. So I know some of us have seen, hopefully you've seen some of the other sessions and been involved. The idea is to really in these sessions is to talk about harvester setup and how to help you guys with your using harvest weed seed control tools. I will try and do less of the talking because there's two guys there, including Newms, who will join us shortly, who've got lots of stuff to add. Before I do that, just a reminder of some of the terminologies and despite the fact we're all talking the King's English now, there are some things that are different. So when we talk about combines or harvesters in Australia, we may call them a header, but for terminology basis, we'll call them harvesters. So whether it's a red, green, yellow, or black, or whatever it is, we'll try and call them harvesters. But if you're not sure, please raise your hand or raise a chat question if you've got your uncertainty. And also those things that we use to go and cut the crop, we're going to call them header fronts. Okay, they're header fronts. So we get some clarity on some of those things, and there'll be other things that come up. The other thing is, as I said, we may all be speaking the King's English. I speak with a strange tongue. If you're not understanding, if you've got a question, I will try and speak slowly and clearly. And if you're not getting something, please raise your hand, because I know this is going to be available for other people to come into and listen to the recording. So we want to make sure everyone gets the clarity of the question and the clarity of the issues that are coming through. So, okay, we're going to be talking about green material today. So hopefully you can all see the slide. What we want to go back to is to go, okay, to start with, we've talked through the front and we've got to get the material onto the front. We then went through into how we then thrash that material and where it goes in the machine from the thrashing section and the implications of that. We're going to revisit a bit of that today because it's critical to what we do. Because today we're talking about green material and harvest weed seed control, or specifically because if you're using mills, here's the implications there and what can we do, really what you can do. And remembering, as Brett rightly says to me every single time, it's what we've done here works here, but may or may not work for you. The only way you're going to know is you're going to have to try. And that's what it's all going to be about, is having some tools to kind of try. So Brett, I might hand over to you. You're going to have to tell me to move the slide. So the first slide I'm going to put up, just a reminder of the flow. If I can get my screen to move. Excuse me. Do you want to take us through this slide, Brett, so we have a bit of a refresh on what Nick Berry's put up for us?
Yeah, sure. So basically, when we go and take a look at this slide, and I mean, and effectively, this slide is based on a rotary machine. So it could be a green machine or a red machine. So effectively they're the same. Only difference being that at the end of the separator section in the green machine will be a beater, and in the red machine there'll be a chopper if you've got an internal chopper. No different otherwise. And what we call an open separator. Okay, so material that we want to put on the sieve is thrashed and separated in our thrashing and separating area, and then that material lands in a preparation tray or on an auger bed and is transported back to our sieves. Just remember that every single thing that we're doing in our threshing area determines what is in that mixture that ends up on our sieve. So if we're pounding all our straw into little tiny pieces, we'll have all of these little tiny pieces of straw. Okay, so the more material that we end up with on the sieve, the harder the job for our sieve and our fan system to sort that material. But herein lies the next thing. With a normal harvester or the normal combine, we're going to discharge that material out the back and it's going to be chopped, spread, whatever you end up doing. When we go and put a mill in there, we want to collect that material that is ejected off the sieve. So anything that's bigger than our grain, effectively, we want to blow out the back of the machine. That includes any of the green material that we've smashed up and any of the stalky pieces. Our mill then has to process all of that. So that's where our mill loading comes from. And as I said briefly when we were all talking before we started, the enemy of the mill is straw. I did a little bit of an experiment one day in front of a group of farmers over here in the early days of mills, and I'm talking about 2017. Okay, and I had a small handful of straw like this. I could hold it in my hand, and I dropped it into one mill and almost stalled the machine. Okay, so there was nothing else going through the mill. There were a whole pile of people standing there, and I just fed those stalks through. Okay, I then did the same with 2 kilograms of lupins in a bucket, and I poured them into the mill, and it did exactly the same thing. It almost stalled that 7240 that was running at full noise, and all it was doing was really running the mill. Okay, so this is how severe that loading can be if we get it wrong. And everything that we've learnt in the last 6 years, well, mind you, we've been playing around trying to make this work for 25 years, but everything we've learned in the last 6 years is that we have to change the way that we understand the way our threshing and separating system works. Yes, we want to get the grain out, but we need to not smash everything up into dust, which is what we have a tendency to do here in the west of Australia.
So Brett, in terms of then, we know that if we're going to load up those mills where we've seen, I'm just going to move on to the next slide. We've seen, and we've all seen blocked mills, right? And you're saying there's a numerous things that can add to that. One, if I'm correct, if I'm not getting this right, one is the amount of green material, and then the material that we've processed that's overloaded our sieves. So how we thrash it. Would that be correct?
Correct. Yeah.
Yeah.
Yeah. So everything that Cassie and I have been working on now, and that I've been working with trying to make these mills work, has been about getting the separation better, getting the division between the chaff and the straw better, and understanding what's happening in this diagram. Most of the John Deere machines, we actually want to completely divide from the floor underneath the beater all the way to that separator baffle. We want to put a complete division in there. We do not want any fallout of material to land on the sieve. So that means that only the stuff that comes through the concave is going to end up on your sieve.
So you're talking where my arrow is now. You want to keep it separate?
Go back underneath the beater, Pete.
Right down
under
here.
The beater. Go back all the way back.
Yeah, right. Yep. All
under
the way
the beater.
Here. Yep.
And where the separator baffle is drawn in.
Yep.
See, there's a gap between the beater and the separator baffle. No, not that baffle. The added in baffle that's the one.
Yeah.
See how that one is drawn in? That's basically where the separator baffle is going to end up. Yep. But there's a division between the pan underneath the beater and the beginning of the separator baffle.
Yeah.
So that drawing there is showing the back of the straw hood, but that one there is the separator baffle. Yeah. Because what we're doing, the straw has to go over the top of the separator baffle and not go into the mill, go into your chopper, and the chaff stream has to go into the mill because that's got the weed seed in it.
So if we look at can I just say something? Can you go back to that photo of the block mills, please? Right, so if we look at that Harrington on the right-hand side there, that big bowl of material that's sitting on top of the auger there, we can see some fairly long stalks in that. Yep, just there where your arrow is. Yep. So that's fairly large stalks that we've got in there that we don't want. So we want the material to come off of our sieves to go through those mills. Those stalks there, that's no good for our mills. So if we can go back to any of your other pictures, please, mate. Yep. So if we go to our threshing area, and that's what I've said with our previous meeting. Yep, just there. So that's the area where our concaves are sitting in. So if we can keep our material inside our concaves, the bad material inside of our concaves, that will go through our threshing system and through our separation system, through the beater, and then gets chucked out of the machine. So those big long stalks that we've seen in the photo, that won't come into our chaff then. If our concaves in the thresher area, if we've got large gaps in those concaves, that is what will cause those big long straw bits to go through there and blocking onto our mills, because that will fall onto our sieves. And as we know, everything going through over the top of our sieves will go into our mills.
Cool. So you're saying that we want in that area the separation to the thrashing to happen and to keep it close as possible, keep it in the machine,
yep,
following that green, the
to
green.
Throw it out. I know years ago we've been running around telling people to put large concaves in so we can get all the material out onto our conveyor augers, onto our top sieve. Over the last few years, we've started to go away from that and change our concaves to small wire concaves. So all the material that we don't want, that's no good for us, we want to keep that in that separator baffle through the beater and chuck it out on the ground.
Okay. So you're talking, when you talk small wire in John Deere's, what are you talking about? What do you want to put in there?
Small wire in John Deere is the 31 wire concave and a 25 wire concave. That is small enough. I'm talking grains. So we don't want to see any large wires, which is the 15 wire concave or the round bar concaves in it, because it just lets too much material through to go onto our top sieve.
Mm-hmm. No worries. And Brett, from a case perspective, you want to comment on that?
So typically with a mill, if the case has got an internal chopper, it will clear the baffle. Okay, so when we go and add in that separator baffle, if they've got a chopper, you pull that chopper floor up as close to the chopper as you can, and that will eject the material. Most of the mill manufacturers now put an extension on that beater chopper pan. That helps to keep the material airborne, and extends that platform. And we generally don't get a lot of straw fallout in a case. And remember, it's a lot shorter. Okay, so the bum of that machine or the back end of that machine is a lot shorter than some of the other machines. So it quite effectively does that. So
okay.
Yep.
Okay, so if we look at one of the mills now in terms of where the flow is into the mill, this is obviously the SCU on a John Deere. Can you tell us what's happening here, Brett?
Okay, so let's focus on the top arrow first. So you can see with the SCU, they do add a beater extension. So that's where that arrow begins. And then it will follow the straw hood, right? Or sort of the back wall of the chopper and feed the material into the chopper. Okay. Yep. And underneath that arrow, you see the add-in divider panel. Okay. So
are you talking down here or this bit here?
Go up, Pete, up. There's your divider panel. Okay. And and you see there is a gap. So there is nothing between the beater extension and the beginning of that separator or divider panel. And this is the point where if material isn't airborne, it can hit the front edge of that and then it falls and it will feed directly into the mill. Okay.
Yep.
So that's a challenge, right? So there are panels made that we can put in there. Cassie has seen those, and we seed terminator guys would do that religiously, because that's your big ticket box for getting material not to end up on the sieve.
So how does this differ to, say, the IHSD? Have they got the same sort of structure and setup from what you understand there, Brett?
Yeah, it is very similar. There's no doubt. All three of the mill manufacturers effectively have done the same thing. Mm-hmm. And it's no different, Pete. We all understand, chaff lining and guys who run a chaff cart and chaff decks. We've got to put a division in there so that what we end up putting into our chaff line is chaff, not all straw.
Mm-hmm. And we'll talk about the baffle. And I know that Ray Harrington's had a discussion with Newms for these guys talking about it, but we'll talk about it a little bit more in a second. So when you've talked about the top arrow there, the bottom arrow, I'm just going to go to it. So that's taking, what's the bottom arrow? What's in that bottom orange arrow there for all mills?
Our bottom arrow is the feed into the mill from off our sieves. So that is our waste, our residue, our materials other than grain, hopefully no grain, guys, that comes off our sieves. So everything that landed on our sieve that didn't get separated and end up in your grain tank goes into that stream.
Right.
So this is the critical point. Now, your mills that you are using are an impact mill. They are purely an impact mill. And that means that the rotating and the stationary parts are exerting or imparting their energy on all of the material that is going into the mill. So do an experiment, go and grab a handful of whatever your weed is and go and get a block of wood and a hammer and just carefully hit it once and see what it does. Hit it twice, see what it does. Keep hitting it until the thing falls to bits and work out how many times you got to smack it. The challenge with the mill is it's got to do this in three processes. It's got the rotating and stationary parts are going to impart their energy onto that product 3 times. If you can't hit it once or twice and turn it into dust, that mill's got to work so much harder trying to process that material. This is our challenge. The dry material will powder up. Large amounts of dry material, even, if it's hot and dry and crisp, they'll turn to dust pretty easily. And, you can put a bale of hay through that thing if it's nice and dry. But if it's a bit green, it won't smash. It'll glue itself to the stationary bars primarily, and then everything else following it will stick to it if there's not enough dry material to clean it. The mill is relying on the dry material going through it to actually clean the rotating and stationary parts.
So you're talking about trying to, we'll go into some more detail on that green material and what we can do. But if I can slide to the next one, for the Redekop, we've got the material going in, and these mills are, you said they're impact mills that are working hard to try and push that material through and smash literally that material as it comes through. And that you're saying, if it's green, or any moisture in it, it's going to impact the ability for it to actually do that. So they've obviously got the ability to put a divert and divert the mill. I know same as applies for the other mills as well. But in terms of this is the seed terminator. What's the difference here in terms of what we're looking at in terms of structure? I can see that same baffle system in place and the same flow. Are we talking the same style of setup here, Brett?
It is the same, and all of the mills are the same structurally. The difference with the terminator is that it has a set of flails in it. So basically the first stage is a hammer mill, and it will much more effectively break everything up so that it will then process by the mill. That's why it'll handle a bit more green material. Okay, so Look, I've seen one of these mills handle 30% green ryegrass in a barley crop. That's a dry barley crop, but about 30% of the product going through the mill is green. The exhausts are green, and they don't block. Uni, Missouri have a case combine with a terminator on it, and there's videos of that all over the internet where they're harvesting ragweed, and that exhaust is green as, and yet it processes it. So they'll handle a lot more material. But that's because of the flail and the airflow and the way that it works. This is not saying that we can't make the other mill work. We're just saying that it actually works a lot easier, but it is harder to bypass and it is more difficult to loss test.
So just in terms of where we're getting blocks on these mills, I'm just going to go to the next slide. So where are we getting blocks? Obviously, we can see it physically inside the mill, but are we getting blocks around that baffle as well?
Generally not. It'll be the entry into the mill will fill up because the mill can't process the material quick enough.
Right.
So that's what it will do. Pete, just slide back to the separator baffle slide. Even the Redekop one is fine. Go back one more. One more again. Righto. Yep. So when you look at that top arrow, have a look at the area of the entry. Okay, so when you look at the distance between the divider baffle, where that bright orange arrow is, and the back wall of the chopper. Okay, when we go and put that divider baffle in it, and when we go and fit a mill, we push the chopper back and we close some of the chopper entry, right? And typically we're going to reduce that area by around about, or that gap by around about 150 mil. Okay. The problem with that is that when you're processing green material in a John Deere machine, it rolls the material in such a way that you end up with basketball size material trying to enter that. So in green canola, green lupins, and green lentils, that is where the machines block trying to get it into the chopper, and it will block the entire separator. It's not actually the mill that will block it in all cases. So the two things are quite relative to each other.
But so you're saying it's blocking from here because it's rolling it? Yep.
Yep. So the material coming off the rotor is rolled, and then it goes under the beater, and it can't fit through that gap. You're trying to get like a basketball and poke it through that gap.
Right.
Which
so
is
go ahead.
Which is why I started doing what I was doing with the green headers, as Cassie and I have talked about.
Yeah, we'll go a little bit more on that shortly.
Brett, really quickly, there's a comment in the chat. Someone mentioned just ensure the chopper on the Case IH is in high to assist in clearing the baffles. Yeah.
Yeah, well, remember in low, all it is a beater, and it won't give the terminal velocity to the material to eject it over the baffle. So if you are running the machine with the baffle in it, always run it in chop mode. Even if you drop the knife blades out and use it to throw the material, it should be in high. Yeah.
That will be Andrew giving us some wonderful comments. Just in terms of the baffle, I'm actually going to move on a couple of slides because I wanted, one of the things I know Ray and Pete were talking to the guys about was the implications of the position of the baffle. And Ray had a comment, and he was talking about backflow pressures under that baffle if it's in the wrong position. Is this something you've seen, Brett? Is this something you've seen, Cassie? Brett, do you want to comment?
So if you go in to a new flagship combine that has harvest command, have a look at the sieve pressure sensors. Go and jump in a machine that's doing 40 tons an hour in wheat crop, and go and look at what those sieve pressure sensors are, and then jump in a machine that's got a mill on it. Those sieve pressure sensors can go through the roof, and typically in some applications we have to turn them off because it messes with the harvest command's head. Okay, and that's all due to back pressure. Okay, positioning of the baffle is critical. and I try and get the baffle as far forward as I can and as low as I can to the sieve, I never ever get sieve baffle blockages. They're always over the top of the baffle, if that makes sense. Because the sieve's moving, it's going to shove everything out the back. Okay, it'll get a little stack and it might sit up there, but as the sieve moves forward, that material will fall into the mill entry.
Yeah, you were having a good chat with Ray and another call. Do you want to give us some comment on your experience and what Ray was seeing?
Yeah, thanks, Pete. You're right. It was the early days of having that baffle.
You might need to kill your video, mate. We're losing your audio.
Baffle 30 off. Hopefully that works better now.
Yeah, beautiful.
Ray always talked about that leading edge of that baffle being about 30 centimetres, 12 inches above the back of the sieve, and the leading edge being about in line with the back position of the sieve. And that was a good starting point. But I think what we found was that there's so many different machines, and I think Brett might comment with the flagship case machines, the baffle really changed. It ended up being more like a cover on the spreaders, on the straw spreaders. And and it sort of sat further back than that and a little bit lower.
Brett, we've got a few non-flagship type machines. We've got some 8120s, 7230s running mills. We've also got guys doing, got some harvest chaff lining. Any comment related to those style of machines around the baffle?
So this photo's out of Ray's 2388, and I remember that machine. And so anything 10 series, 70, 10, 80, 10, 90, 10 onwards is what we would call a flagship. So Pete, all those 72, 30, 81, 20, all flagships. And typically the baffle starts behind the sieve, okay? Because what we say is if you're going to run a mill on one of those machines, you need to have a machine with a chopper in it. So we retrofit the chopper and do that as part of the mill installation. And then that will throw that material far enough back that it will clear that baffle. One of my customers over at Darren has actually just moved his baffle forward by about 4 inches, 100 mil, and he said it made absolutely no difference to it. So, and that's in a flagship. So,
okay,
yeah, no difference whatsoever. He was chasing mill loading, but we went and did some other things afterwards, and that made the difference. And it's all about, you know, the way that you set your rotor up and concave positioning and so on and so forth. I mean, look, even, you know, when Robin and I went and did Ray's header, the change to it was immediate. Okay. So, yeah, the concave positioning and the way that the machine separates its material makes the absolute world of difference to these machines. It's no different. It's what we're doing with the John Deere's as well, dense packing the rotor, for the same exact reason. It changes the way the material flows, and it changes the way the machine processes the material, and it makes it easier for the mill and the chopper to work in sync with each other.
Great. Look, I know that we've got Andrew Veering there, so we'll get him to comment in a second on how the IHSD is coping with green material. I know chatting to Marnie Strawn from Redekop the other day, they were talking about some solutions in dealing with green material, particularly in soybean, that they've been trying and testing, particularly around the baffle area. I can't comment on it, but I think it would be something useful to get some feedback on as opposed to this session. If we could get some, I know that Eric and the guys will listen to this, but Emily, if we could get them to respond and perhaps send something out, there might be some, see how things have gone. But Andrew, do you want us to give, Andrew, can you give us a bit of a heads up? What are the things the IHSD guys are doing to look at managing green material?
Can you hear me, Pete?
We can hear you great.
Yeah. Just everything really what Brett and Cassie have been talking about, but specifically for IHSD, we've had a fair bit of exposure this past harvest in soybeans in the States. And it comes back to everything that the guys have been talking about all the way through this program, is that setup and keeping that green stem, especially what we see there in that IHSD tub and in the mills. Things like the beta blanking plate, that's been a big success. And changing your rear section, your modules, without losing grain at the back through rotor loss. We've seen a significant improvement in performance, like doubling tonnes per hour, and actually maintaining normal combine capacity of what they've seen prior to a mill without any choking or blocking.
That sounds very impressive.
Yeah, so it's been, you know, been just a learning curve for those customers, and this is what all these sessions are about. We've had some remove the baffle when required, but generally not to separate that straw. And as we talk about, it's that key is to get that balance of the straw and mold going into the mill.
Yep, absolutely. What the guys are talking about. Yeah, perhaps we can try and grab some diagrams off you. We can chuck them into the slides to make them available.
Yeah. So the biggest thing we've seen is where we're still running what we call the skip wire or large key stop grates in the back of the flagship machines, and we're purely overloading with over thrash material down onto that pre-sieve and onto the sieve, which allows all that long material that Cassie and Brett are talking about to enter the mill. As soon as we can remove that out and put that back in over the chopper and over the baffle into the spreaders, we see that drastic improvement.
So Andrew, I'm hearing that setup is critical to everything else that we do, that you've been telling us about as part of the clinics as well that you were involved with. I think I might push on to the sort of what are our options. We really have with mills the opportunity either to bypass, which is a decision, but perhaps I might throw a question to first you. When are your guys choosing to bypass the mills? What's pushing that decision?
Purely when it comes to bypasses, and typically in Australia, where guys are really pushing the fringe of when they should be harvesting and when they shouldn't be, whether it's early in the season and they're trying to get a break, or there's weather approaching and the crop moisture's right, but we haven't got necessarily warm days and they're pushing late into that night, whether say it's windrow type crop where the crop's dry but the atmosphere's damp. As the season's progressing, we've got a lot of bogging and moisture issues across Australia, especially on the eastern seaboard. So I've had even last week a machine, and these guys are not new to harvest weed to control. They're 4 years in. They've gone to new combines this year, same flagship machine, and we're bridging because they've got a lot more green stem, a lot more biomass in their crop this year. So once again, fair bit of that will resolve with just changing combine setup, because we just have far too much long canola stem coming down.
Yeah, okay. Cassie, what are your guys doing? When are they thinking about bypassing? What's driving it?
Just productivity, mate. If they can't get going, and they've got large schedules in front of them, ahead of them, where they need to harvest 15-20 hours a day, and they lose ground speeds, that's pushing them to bypass it and just get rid of it, just throw it over. I think sometimes they need to make the decision whether they want to get all the weed sets or whether they want to get their crop off. And as we all know in the farming business, if you're getting old up and it takes too long, you'll get rid of the things that's holding you up. So that's what I've seen. Bypassing is just to get more productivity through the day.
Yep, fair comment. I might throw a question to Nooms, because we put up on the screen their desiccation, and my knowledge is minute, and I know Nooms is an awful lot better than mine. Nooms, why why do guys desiccate here, and why do they not? What's the implications of desiccation? You with us, Pete?
I am sorry, I just dropped out for a moment. What was the question, Pete?
I said, in relation to desiccation, can you give us an idea why do guys desiccate in Australia, and what are the implications?
Yeah, I guess in Australia we're harvesting into summer, so for a lot of our crops they don't require desiccation, all of our cereals and even quite a few of our legumes. But we've gone to direct harvesting or direct cutting canola, which has become very common. Instead of windrowing, there's a lot of direct cutting of canola now, so that's probably become the main reason for desiccation, just to aid the ripening of the canola. And drying it out to allow us to get a start on harvest. Also happens in some of the legumes as well, lentils probably particularly. It's only a small proportion of our crop really. It's our direct harvested canola, and really that process is spraying with dicot, often by an aeroplane, and then harvesting about a week later. I would some of the Americans might like to comment. I would assume that desiccation is much more common there as you're harvesting into winter. But yeah, be interested in people's thoughts.
Can we get any comment? Rodney, are you desiccating?
No, we do not desiccate our wheat. Our sunflowers we do at times, but we did not this year with the seed destructor.
Okay. And did you have blocks this year?
Yes, we finally had to take the baffle out and do away with bypass the seed destructor because it would not stop backing up. The green heavy stalks of the sunflower would back up into the rotor, and we dug for hours to dig that out the first time it happened. But desiccation might help some on the sunflowers, but that stalk is still pretty heavy and tough, even with desiccation.
Yep. Fair comment. We talked to Taylor earlier, and he said they weren't desiccating up in Kansas. Michael, do you want to give us any general comment on what's happening in North America around use of desiccation?
Sure. So mostly the frost basically acts as a desiccant to kill the plant, and then it just eventually will dry off. It takes a while going into winter versus going into summer, but it does eventually happen. So for most of the U.S. and soybean cropping areas, desiccants are not commonly used. The exception to that would be further south, the Gulf of Mexico kind of coastline proximate to that. So Texas, Louisiana, that's where you'll see more desiccants commonly used, because they'll just stay green for so long. If you don't, the soybeans will. I don't know. I see Drew Lyon on. Maybe he could comment on like Pacific Northwest area. I'm not as familiar with that part, but yeah, it's generally desiccants are not used for most of our soybean harvest.
Yeah, we do use some desiccants in our chickpeas. Indeterminate crop, so low wet areas will stay green, and so they do use desiccation with some rather commonly for chickpeas, sometimes for lentils, but not for wheat, but for some of the chickpea things. One of the recently, Michael Walsh was out here, and we had a little meeting with some growers near Pullman who had a seed terminator, and they were talking about canola harvest. And what they did is they took some of the bars out of the cage, so they didn't have as many bars for the chaff, for the things to go through. So it lowered the kill rate, but it allowed them to move through the crop, move some more green material through the crop. I don't know if that's something that's commonly done. And I think they had some where they took out just a few bars, some others where they took out more. And so depending on how much that was slowing them down or causing them problems, they would reduce the number of bars in there, and they were just willing to give up the extra kill rate to move a little faster through the crop.
Brad, do you want to make a comment on that?
So, yeah, that was trialed and tested this year in Canada and the US, and then those change screens were available for this harvest over here. So, Pete, those were the full bypass screen, the high capacity, and the lupin screen, and there's an intermediate screen as well. So basically, all it's doing, it doesn't change the rotor in any way, shape, or form. It's just a removable separation screen, let's call it. 5 bolts, whiz the thing out, 15 minutes, you change it from one screen to another. And yeah, those trials and tests have led to the commercial availability of those screens over here. And I talked before about high capacity screens. They are probably in the US, they probably call them a green screen. They do in Europe. All the machines that Seed Terminator export out of Australia to Europe go factory equipped with green screens. They don't go with the high kill screen that we would primarily use here in Australia, purely because every machine that's in Europe is on a organic farm, organic property, and they don't use chemicals of any shape or form. So they obviously have the green material challenge. So yeah, they're all shipped to Europe with green screens. So,
Mate, my understanding is that I don't know whether the other mill companies are offering alternative screens. I do recall Redekop were talking about it, talking the ability to do it, but I don't know whether it's a priority for them. And I don't know whether Andrew can comment on what IHSD are doing.
Yeah, Peter, we do have a high flow, what we call stator, which is similar to the screen.
Stator, yep.
So it is sort of limited, and it is only in the Australian market at the moment.
Right. Okay. So there's a possibility for that. Okay. So we talked there. So desiccation could be an interesting one to look at. Brett, we were talking earlier about you've seen desiccation used in lentils, particularly where someone's using a mill. Do you want to give a comment on that?
Kath, you would have seen these probably if you was involved in it, but early on, we don't grow a lot of lentils here in Western Australia, and we don't actually have a lentil grower that has a Seed Terminator in WA, bearing in mind there are 350 of them over here. But in South Australia, we have a lot of guys that's all they do. They only grow lentils. And absolute nightmare unless they desiccate. And often they have to double knock them. If they go and desiccate them once, that'll get probably 90% of them. But if they've got good subsoil moisture, they're going to have to go and do it a second time. So they usually do them twice, 3 to 5 days apart, and then leave them 7 days and then go for it. Because if they don't do it, it blocks both places. It blocks the chopper entry and it blocks the Terminator entry.
Yeah, we do have the fellas with the lentils here, and it's nice and clean. The paddocks are clean during winter, but then hit September and it starts getting a bit warmer, and then all the thistles and everything started to come up through it. So yeah, they do spray it. Like if you go past the lentil paddock, sometimes you can't even see the lentils in it for the weeds that's in it. So they do spray it, and there's a lot of green material in there. So there's no other way. You have to kill it before you can put it in. And it's some of it is those thistles, so it's very sappy. There's a lot of juice coming out of them.
It would be good to get some feedback from some guys in North America, maybe for a future one, in terms of where desiccation may or may not be applicable. I don't know whether it's applicable in soybean or in certain areas where it may apply. James, I don't know whether you've got any thoughts on that.
Yeah, I don't know. I guess one thing I was going to add, I mean, a lot of what we're talking about is getting green material through these mills, right? And well, probably without completely letting the cat out of the bag, one of the mill companies is going to very soon go public with a totally different mill design. And my understanding is it's going to be a whole lot better for the green material. So I guess I'd just say watch this space very soon on this issue, because it seems that the green material blocking our existing mills, you know, is a big issue. That's what we're talking about this morning. Obviously, I've got a feeling that, yeah, there might be a better mill design for North America, not too far away.
Yeah, okay. I think that's a fair comment to us to go back to what Andrew was talking about, is reminding ourselves that the first thing we've actually got to do, and that's how we process that material in the first place. So I'm going to move on to the how we thrash that material. So look, Brett, do you want us to take us through? You've done this a few times in terms of putting this on machines. What we've thrown up there, can you explain to the guys what they're looking at on the screen there and what you're doing to deal with this issue of not, I think the words you're using is not making the straw too small, keeping it in that threshing and separation area. What are you doing there on this case machine, and tell me where to point?
So just point at the gold bracket at the front point. So righto. So the case, flagship, and even the mid-range, the smaller case machines, you have the opportunity or the ability to change their pinch point. So if we look at the diagram on the right, and you have a look at the arrow number 10, it's pointing at a rasp bar, right? So that is the 6 o'clock point of our rotor. So our factory set, bearing in mind the factory doesn't set it, the dealer sets this when they PD the machine. The factory just put a gauge block in it. That factory set point, the clearance between the rotor skin and the very first rub bar on the left side concave should be 81 millimeters. Okay. We then go up to the side where the number 8 arrow is, the third bar from the top. And when we zero it, that measurement front and back of the concave should also be 81 millimeters. That's the factory zero for that concave. But what that does is that gives us a single bar contact point at 6 o'clock. And if we understand what happens with threshing, so there's a wedge on the right-hand side, the material coming up your feeder house comes around the transition cone and enters the right-hand front concave, above that right-hand front concave, and it runs all the way around that concave. The right side of that 6 o'clock point is squeezing the material in, and virtually no separation occurs. Once it goes past that pinch point, that's where it does its thrashing. And then after that, the wedge starts again and it widens to the left-hand side. That's where it unloads. So we've got our unloading point basically on this starting at 7 o'clock. The problem with that is in cereals where we're running a close concave, and when I'm talking close, I'm talking lower numbers, but not single digits. When we're running a single bar pinch point, about 80% of our separation occurs on the left-hand side. So our left-hand side of our sieve is loaded. And you don't see this till you go and put a mill on the back of the thing and it goes left mill speed alarms all the time and left mill blockage sensor alarms all the time. And so we've got to look at this and go, how do I even my sieve loading up and what can I do? Well, those little gold brackets are the ticket for a case header, for a case combine. They give you the factory ability to slide that concave position left and right. So over a number of years and through hundreds and hundreds and hundreds of trials and tests, I've found a way, or found a position where it works better. Okay, and now there have been hundreds of machines in Western Australia that have had this done to them. Not just flagships, older, smaller machines as well. I mean, on Monday, I did an 8120 and I did a 2388. Same process, slightly different, mechanism, but both machines, we saw 50% gains in performance as in tons an hour throughput in canola. Righto, so it's worth it. But the side benefit from that is by moving that pinch point, we increase the thrashing surface area 4 or 5-fold. Okay, so if you're still going to run your concave at 6, don't do it because it's going to turn everything in your thrashing area into dust. We're now going to open that concave in a cereal to mid-20s to mid-30s on that concave opening on a flagship. So basically 3 or 4 times as wide. What it does is it ends up giving you a bunch of horsepower, giving you the ability to poke a bunch more straw through the machine, and it still thrashes adequately, still does the job with a greatly reduced load, and your throughput goes up because the straw goes through the machine in one bit. I mean, the ideal thing is that harvesting wheat, we can get straw and the wheat head backbone come out the back of the header in one bit with no grain on it. Okay, so that's the ultimate that we can do. And if we do that, what ends up happening is our sieve loading goes away and we get lower sieve loss and we get lower rotor losses. Okay. There are a couple more things to this, but.
Yeah, just before we move on to a couple more. So given the guys are also doing corn and soybean and sunflower, can you make a comment on any of those crops from your knowledge or just even your thinking?
So initially I was concerned about shifting this pinch point like this if you're going to harvest harvest corn or sunflowers. And then I started remembering about being 10 years old and poking sunflowers through a 585 Massey header. And we did that quite successfully. And I reckon if you can get sunflowers through that thing, this will be a breeze. But you'll probably end up running a really wide open concave. You won't end up with all of that straw and all of that stalky material because largely it's going to belt the hell out of the head, get the seed out of it, but the stalk will stay intact. Okay.
So when you say really wide, what do you mean by really wide?
Concave, canola settings, so 35 to 40.
Okay, so I'm going to ask a question. I think, Rodney, you said you're doing sunflowers, is that correct?
Yes, sir, that is correct.
Well, what you running your concaves at, Rodney? Obviously, you're running a John Deere.
So I was sitting here thinking, I believe we're running close to 40. I mean, it don't take a whole lot to get those seed out of those heads. So I would say between 35 and 40 on our concave, but I don't have those settings in front of me. I'll look them up on my phone.
It'd
be good to get. The indicators on the two machines are calibrated differently, so the numbers don't correlate from one color to the other. But,
so just as a general comment, it would be good, Emily, if we could get some feedback from guys who are running case machines and get some settings from them on what they're doing in both their sunflowers and also soybeans. So we got a bit of a feedback. Brett, any comment on soybean and whether this is going to work?
It'll work just fine. So basically soybean is very like a lupin or albus lupin. They'll harvest the same as that. Not really a great deal difference between our edible beans, faba beans, stuff like that. They'll harvest like that. So, yep. Okay. If you have a look at this machine, our left-hand photo, so it's got a helical concave in the front. So anything that thrashes really, really hard in that number one position works really well because we want to do all our thrashing on the number one concave. The next two rows in this machine have got round bars in them. So round bars in the last 2 years have become my favorite secret weapon. Round bars are much gentler on the straw and don't smash it up, but they do promote separation. This particular machine has a set of Gordon rasp bars in it over the threshing area, and they work really, really, really well, but do increase engine load. So, you've got to weigh up, engine load versus throughput versus losses. And so that should work fairly well. But the thing that you can't see, guys, is that the separation area in this machine has 34 spike rasp bars in it. So any of you guys that have harvested rice will know what the spike rasp bar is, and you can't really see it, but you can sort of see the spike. We use the spike rasp bar to agitate crop mat, and what this does is it's provided us a huge reduction in rotor losses and a lot better separation. So it's been one of the big things. But what I've learned is you bang the spike rasp bar in, leave the concave where it is, and it costs you a fuel burn and it costs you some horsepower. And it doesn't necessarily equate to reduced rotor losses. We've got to do these things collectively. Okay. And Emily has got my my cheat sheet. Okay.
So we could chuck that into the slide set, I think, Emily, so people could access it. Brett, on the right-hand side and on the left, there's some numbers that are being put on white marker. What the heck are those?
So these spike rasp bars from factory can vary up to 200 grams. And if you had a whole pile of heavy ones in one spot, you're going to end up with a rotor shake. So anytime we're ever doing anything in one of these machines, I'm going to weigh every one of these bars and then pair them up. Just remember that all your rows of rasp bars, don't put spike rasp bars over your threshing concave, only your separating area when you're harvesting cereals. And every one of those rows of bars, there are 4 bars on there. So that means you pair them up and bolt them on opposite each other and keep your rotor balance intact. Okay.
So you mentioned a hook rasp. This is similar to a rice bar, is that right?
Is a rice bar. So if you buy a machine with a rice rotor in it, right, it has 106 of those bars on it. And that's been the same since the day of the 2188 when they released the AFX rotor. Okay. So, and effectively it's the same part. So if you've got an old machine wrecked out the backyard, you'll go and have a look and it'll have spike bars in it.
Yeah, great.
Maybe, because the 2388 that I did on Monday has got a standard rotor in it. So there you go.
Okay.
Brett, do you want me to drop that cheat sheet in the chat or?
Whatever you want to do with it, Emily. The case guys can happily have a read of it, and if they need to contact me, they can. It's got my email address on the top of it. So
perfect.
Yep.
I'll do that.
All right. No worries.
So any other comments on what you're talking about there, Brett? To go back to Andrew's comment, is we're trying to make sure we do everything we can to keep that material in to the thrashing area and the separation area in terms of that straw, and not over make it too small so we end up with those big pieces that come through. So any other comment for these guys, or can we move on to Cassie and talk about green machines here, which I know you've got some comment on, but any other comment or advice?
Give it a crack. That's the only thing I can say. Look, the only way that we learn is to have a go. And if it doesn't work, then you put it in the, I'm not going to swear, the stuff up book and go, well, that was a complete stuff up. That didn't work. So I'm not going to do that again. But if you do have a go and it doesn't work, please tell me why it didn't work.
Yeah.
Okay. Often what I'll do is I'll have a guy who'll ring me and say, I've done all your stuff and it doesn't work. I go, right, I'm going to get in my ute and drive there. I'm actually going to drive 500 kilometres on Friday to a machine that the guy said, I've tried it and it doesn't work, and I'm going to go fix it. Because generally it'll be something silly. When you do this measurement, you do it with a micrometer. You need to get it to within a millimetre of where you want it to be. And I know it sounds stupid when we're going to run the concave this wide, you know, but if you don't, it won't be successful. Okay, so I've moved them 4 millimeters and completely corrected an issue, and they said, "Oh, we thought that was close enough." Well, no, it's not. Sorry, you got to be fussy. Okay.
So you on that note, you did actually go and visit one of our good Australian guys who was in the first workshop, who tried putting in rasp bars down in Victoria. And what was the feedback from that session with him and his team?
They actually said it increased their engine load and didn't increase their capacity or separation ability. But then we went and did it again, and we didn't do that machine. Those machines were at the dealer, and so we didn't actually get to see them, which was unfortunate.
Yeah.
But I don't know if they've changed that back, Pete. You will.
They are going to change it back. So I think one of the comments, just so to put it in context, they had tried it only in canola. And they had done a couple of goes, and Brett sat down with them and went through it with the whole team. And the first comment they said is, we didn't give this a go. We actually need to give this a go, and we need to do it properly. And we haven't got the measurements right. So they put their hands up and went, mea culpa, we haven't got the measurements right. We need to try also another crop. So I think that's quite important.
Just a comment from me, Pete. Yeah, I mean, you've got to ask the deeper questions. I had a call from a guy last week, and he was saying, look, I've tried everything. I've done the concave shift. I've done the spike rasp bars, and it hasn't worked, and, so on and so on. And then I put Brett onto him, and I think Brett's who Brett's referring to, that he went to on Monday. And sure, he'd tried some things, but then he'd moved it back, and he didn't have a full rotor of spike rasp bars, did he, Brett? So he'd you've got to, dig a bit deeper than I did. Brett sort of knew what questions to ask and knew how to really make sure that they had actually done what he was suggesting in full. And I guess the other thing I'd just add, Brett, you said just have a crack and try stuff. The one thing I would add to that is test with the drop tray as well. I know we carry on about that, but as you have a crack, test with the drop tray just to double check everything. Yeah.
Yeah.
I'm not going to get in a ute and drive 500 Ks to a guy who hasn't tested. And that's what I tell them. If you're not testing, you go ring me and say you got grain on the ground. I go, how much and where's it coming from? And you can't answer that question. I'm not going to jump in my ute and drive 500 Ks and sort your stuff out. You have to be willing to do this. And that means test. Yep.
So just on that note, I might get Cassie to comment on what he's doing in John Deere's. I'm just going to move to the next slide. And after that, I know we've got Eric on. I might ask him to comment on how they're looking at managing green material with the SCU. So firstly, Cassie, do you want to take us through what's happening here? What the heck have you got in your hands there, and what's going on? Have I lost you, Cass? Well, we haven't got Cassie. Maybe, Eric, it may be a good opportunity for you to give us a bit of a heads up what's happening for Redekop. And I understand you've been trying some stuff out with soybean and green material.
Yeah, so I guess for those that aren't aware, obviously there's always going to be a risk for buildup and baling of the combine with green material. And so that's something that, at least for whether they're grow cooperators or even customers here in the US, has been something that we've been focused on to try to alleviate and design out from a part perspective. And so, right now we've ultimately have two different solutions that, obviously are mechanical solutions to try to alleviate that, to maintain the combine itself to continue to run in the field, and the guy doesn't have to, completely clean out or unbale the machine, which is not a fun task. So the first kind of what I'm going to say is a more inexpensive option is I don't have any pictures here, but what we call a tine deflector kit. So think of it as a finger style system that brackets on to the beater floor and provides, say a 2 or 3 foot extension of these tines that extend the floor past, our internal door, our internal baffle that feeds then into the SCU. So that's, essentially option one. The second option would be a conveyor that is a hydraulically driven unit that would basically, again, extend the floor of the beater itself, another 2 feet or so. So both options have run here in Illinois, also in Nebraska, and kind of a test environment for us, both in the US and in Canada. So both solutions are running. We've had fairly good success there, but kind of what we're evaluating right now is the cost and the business side of stuff to say, hey, what makes more sense for a grower to have if it is a risk for him to run green soybeans, especially before it frosts in parts of the Midwest or other states as well. So
thanks for the feedback on that one. I know that Brett's tried too some an extension in there too for Seed Terminator. Do you want to comment on that, Brett?
Yeah, we do that. So the Terminator has an extension on the beater, and then a little baffle that drops in, which is loose unless the machine has an overshot beater, and then it's bolted down. The challenge is getting material to flow off it. So, yeah, as I keep saying, baffle position is critical. The guys in the eastern states learnt the hard way last year. And look, I reckon remotely I moved 10 or a dozen Terminator baffles during harvest last year to allow that chopper entry a bit more room. Yeah, and so that, and also the moving floors. So I built prototype units for CNH for the case platform, for the New Holland platform, and for the John Deere. But Terminator build an internal draper for the New Holland product, but have never marketed the ones that I made, the original ones that I made for both John Deere and Case. So those are still in my shed. So yeah, that could be interesting. I might have a play one day.
Yeah,
but we've been talking about putting one into a Case 7120 out at Condinin, so Pete knows who that is. Mm-hmm. But it didn't go in this year. They did a couple of other things instead, but it's still on the drawing boards to go into it next harvest. Maybe. All right. We'll see.
Well, let's see. Look, I might get you to comment on what we've been doing with dense packs and what you and Cassie been doing on dense packs. Unfortunately, Cassie's had telecommunications failure where he is, which is one of the challenges we have with these things. Being in person, no one just falls over. It's so much easier. So Brett, do you want to just talk us through what's Cassie doing here? What's he got in that on the screen there on the left and right? What's he up to, and what were you up to? Because I think that's
so Cassie and I came from different fundamental ideas about the green header. Purely, I only spent a year with a green header dealer, and that was enough for me. But having to deal with terminators, the largest number of terminators in WA are on green machines. So, you just suck it up and deal with it. But what we learnt was that you can't move a concave on a green header. You've got to do something different. And to get effectively the same result, I took a leaf out of the old rice book, and in the rice machine, they actually have a dense pack of small grain rasp bars on the rotor. And so the photo on the right, that's what we're actually doing. And the machines that I initially tested, I would do one machine with dense pack and one without, and run them side by side in the same paddock. And what we saw was capacitive increases 30%, and our losses dissipated, and the spectrum where our rotor loss came in moved up. Okay, so basically what we learnt was 35 to 37 tonnes an hour in cereals, wheat, barley, we were getting unacceptable rotor loss. By putting the dense pack into those machines, we could get that up into that 45 to 47 tonne an hour mark. So it was a pretty good experiment. The end result of it too was that the machines that I tested that had mills on, the left-hand mill loading went away. So instead of them wearing the left-hand mill at about double the rate of the right, they're wearing much more evenly. The other thing is that we didn't get mill speed alarms and mill blockage alarms out of our left mill that we were getting before. So those things. Also, the first three machines that I did, these guys always got green canola blockages at the start of their season with a standard machine. They would block the chopper entry. Okay? No more. Never blocked the header since. Never blocked the machine since. And one of these machines I sat on as the rain clouds were coming in, and we did the last 4 hectares of his paddock in the rain in Windroad canola with an S680, and it was still doing 20 tonne an hour. Okay, so this whole process works really well. And have a play. If you can't get small grain rasp bars, modify the standard John Deere rasp bar.
So Brett, on the left-hand picture, I think Cassie calls that an interrupter bar. And what's his purpose behind that?
So I'm just getting to Cassie's bit with his interrupter bars.
Sorry,
so, that's all right, mate. No worries. So the interrupter bars go into a standard John Deere concave, and effectively what they're doing is adding the interrupter bar between each bar in your standard concave doubles the threshing surface area of the concaves that you put them in. Okay, so Cass's recommendation is you put them in the front concave. Okay, it does 2 things. It holds the material in there, right? Increases the thrashing surface area, and means you can open your concave a bit wider. And by opening your concave a bit wider, right? And you've got to do that when you put the dense pack in there anyway, because if you don't, it will pulverize everything into dust, okay? And increase your sieve loading. We don't want that. So you can run your concave a lot wider, generally about double the number that you used to run before. And when I'm talking about this, I'm talking about cereals, okay? Does it work in canola? Yes, it does. Does it work in lupins? Yes, it does. Will it work with corn, soybeans, sunflowers? Absolutely. We haven't yet found a downside to any of this, okay? Right, so adding the interrupter bar increases the thrashing surface area of that concave, and it will hold more straw in, right? So we want it to do that. We want the straw to stay in there, and we want it to be intact, and we want it to eject at the beater in one bit if we can. The second thing that the dense pack does is it stops the rolling motion inside there, and we don't get those balls that block the chopper entry when you're running a baffle. So if that's a problem, once you put a divider baffle in to run a mill or any other harvest weed seed management tool, if you're getting blockages at that entry, and I wish I still had my other phone, I have a beautiful photograph of one of these balls as it's entering the chopper on the far right hand side of an S680. And I mean, we opened the door to have a look at some other things, and you can see this ball wedged in there. Okay. It changes the way the machine works.
So to that element we talked earlier, which is going, what can I do to stop blockages, whether it's in the mill by sieve loading or size of material, or at the baffle? We're trying again to keep it up front in the thrashing area in the one, and then keep it close. And then the next step, I think you're same as with your case, is what you're doing in the separation area. Now, what's he doing here in the separation area?
So with the standard John Deere, there are 2 versions of the grate. Okay, so there's a heavy duty grate, which is like a big coarse finger. You don't have to touch those. Those separate really, really well. As Pete, you know, one of the 3 machines we have at Three Springs is like that. The standard separator grates, those fingers are really quite close together. And for the bulk of what we're trying to do, once you put the dense pack in and you run your concave a lot wider, we end up with a lot more intact straw, which is just going to process through. To get the material to separate a bit better, what Cassie has been doing is taking every second finger out of the front 2 grates in that separation area. And what that's done is it's opened it up and it's reduced our rotor loss. Okay. This machine in the photo has got a whole bunch of the actual filler plates or the blocking plates. What we've found, once we dense pack them, we take all of those off, and our sieve loading ends up pretty well even. Okay, it's a lot better. So these things have all worked in our favor, not just to be able to run a mill, but also just in a standard machine to be able to get better separation and better capacity.
So he talks about them being anchors because I think he describes it for trying to put these filler plates on the right-hand side because you've got right-hand loading is almost counterintuitive. Is that correct?
Correct. What you want to do is you do want it to come out. You want the material to come out. And my recommendation with those is if you have zero rotor loss and you're getting sieve loading, start filling the back separation grate from the bottom, right? Because the material will fall out through the bottom. So what we'll do is we'll put those from the bottom first so they can separate on the sides rather than in the middle, okay? And do that until you get rotor loss. Fill the back, bring it forward until you get your rotor loss, okay? And that will reduce your sieve loading. Okay.
So if I look at the flow again, we've kept again can you remind guys what's happening here again? What you've just done both with the case and the John Deere?
So basically, what we're trying to do is transmit the straw through that threshing and separating area intact and eject it through the beater or chopper over the baffle and chopped and spread. Okay, so we get rid of it. But we want to separate what we want. So that being our grain that we want to collect and the weed seed that we're trying to harvest and process through our mill. Okay. What we're trying to avoid is we're trying to avoid high sieve loadings. So we're trying to avoid green stalky material, even pieces of stalk. That's what we're trying to keep in that rotor cage. And we're trying to eject it with the volume of straw and only put on the sieve as the volume of grain and harvest weed seed that we're trying to collect and deal with. Okay. The lower the sieve loading, the easier it is to tune the sieve, the easier it is to keep the mog airborne, and the easier it is for the mill to handle it.
Cool. I think that's a pretty good summary you've given us there, Brett. I guess I'd like to throw back Emily to if anyone's got any questions. Nooms, or you got anything to add?
I did just see a question from Michael about desiccating in the chat. I don't think we covered that earlier. Michael was asking, does the desiccating keep the stem dry? Is that right? Yeah, does desiccation dry out the stem or the weeds or of the weeds or the crop? And Michael, I guess I'll just answer that by saying we use Diquat. Reglane is the brand name, Diquat. And we're using it by air, and we're often using it at a pretty low rate. So I think the label rate is 2 to 3 litres per hectare. I don't know what that is in your measurements, but we use it about 1 to 1.5 litres per hectare. So we use it at a low rate. We often find we just dry out the top of the crop, and we do a little bit of drying of the stem, but it does regreen pretty quickly after that. So yeah, we probably don't do a great job of drying out the stem. Maybe at a higher rate we would.
I know that Andrew had a question to everyone, which was around is on canola. Are people using pod seal at all in North America? Or Eric, that you got experience out there? Are any of your guys using pod seal within their canola?
You said pod seal? I guess I'm not.
Pod guard.
If they are, I'm not super familiar with it.
Yeah.
Nothing, at least that I've heard of directly from whether they're grow cooperators and or sold machines to customers. I don't think I've heard of that, Peter. So.
Yeah, no worries. Okay. Emily, is there anything else you wanted us to cover? Is there any questions?
I'm watching the chat. I don't see any more questions, but feel free to throw some in, folks, if you have them.
I guess one of the things I feel like I've seen with the various like IHST, Redekop, and with we were trying to put our own homemade baffle for a chaff lining kit, is that the green straw seems to plug up as you narrow that entrance to the straw chopper. Like you mentioned, the green straw really seems to be more of an issue there. Like I feel like we've had more blockages going into the straw chopper by restricting the straw than we have the chaff and chaff going into the mill. So I guess it's maybe just a comment more so than a question, but that does seem to be a key that can be, especially if you're trying to move and adjust a baffle in there and position it and all that seems to be more of a key than than worried about the chaff.
So what we've learned, Michael, with that, I guess you're talking about with a John Deere machine.
Well, I guess where I had the most trouble was the chaff lining kit was on a case machine, but I have seen that on John Deere's as well. Yeah.
So we'll talk about John Deere first. So what we'll do if we're finding that we can't get the baffle any further away and we're still getting those blockages going to the chopper, we'll actually unbolt the corn cob door. When we take that corn cob door out, it actually adds about 60 mil to the narrowest point of that gap, and the material has a tendency to fall through. Also, there are the 3 little crop directors up above you on the top door. So on an overshot beater machine, that door swings out of the way. But on the standard machine, there are 3 little crop deflectors. We'll take the 2 right-hand ones out and just leave the one closest to the middle, and it stops that balling effect occurring on the right-hand side. Okay, so those 2 things might work for these guys. Right. What we've learned is that 24 degrees or steeper, that baffle has to be. If it's anything less than that, the material will stick, right? So you get your inclinometer, and when you're playing around with that baffle and you're positioning it, it can be no flatter than 24 degrees. Otherwise, the material won't slide. Okay.
Yeah,
and then make it out of stainless.
Yeah, we didn't measure it, but yeah, we initially started with something that was pretty flat and then curved down, and that was problematic right from the get-go. But yeah. So the IHSD on the John Deere, that seemed to be one of the problems, is that it narrowed the entrance for the straw so much, but I guess we didn't play with the corn deflector door at all. So that might work pretty well there.
We also Terminator, we actually made a panel that we took that door out. So when we put the Terminator on, we had to push the chopper back 140 mil. And so we had 140 mil filler plate above the chopper, and the back wall was there, and we filled that gap, right? So that's how far back we pushed the chopper. And what we did was we ended up making a new panel, and we took that whole door out and we filled that gap. So with the IHSD guys, if that chopper is back, and I'm sure it is from my memory, you can take that panel out, take the back wall of the chopper, even just move the back wall. You can actually straighten it up, drill a couple of new holes, and then just put that filler plate underneath so that it actually feeds, and open that throat up. It'll make a world of difference. So, yeah.
Redekop, just probably add, my observation is, in talking to people, is that so many of our problems are coming from the baffles, aren't they? We just, it's sort of stuff we've made up as we've gone along, if you like, and people just trying all sorts of different things. And I guess I'll just add the comment that we've probably still got a fair bit of learning to go. We're probably going to keep improving on the baffle a fair bit. I feel like the mills and so on have improved a lot and come up with different options. I feel like we've still got a way to go with the baffle.
Yeah, Andrew, do you have a comment from IHSD?
Yeah, just on that John Deere rear baffle, that's depending on what model residue kit is, whether it's a power cast or a tailboard or an overshoot feeder, that rear panel's changed. So you don't actually use the John Deere panel, and just whether it can be put in around the wrong way. Some guys have had success with it that way, and some guys have had it, there's a green seal on that seals up to the straw wood. And it has been put around the wrong way where it catches material on the chopper.
Yeah. I know with chaff decks, that difference in tailboards makes a huge difference to how they perform. And you've got to have different seals and equipment around it. And I know that Eric's seen that too with the chaff deck there. Anything else? Any other questions? I know we've been going a little while. I know some of the guys may come back with questions once they've seen this on video. If you have, please send your questions through WhatsApp and we will respond.
Yes, and I was just going to add, if anybody is on here who wants to be on that WhatsApp messaging group where the Australian presenters are, and you can have access to them, shoot me an email. I just put it in the chat, and I think most people on here have my email. So
cool. I might hand back to you, Emily.
Yeah, well, this was our final meeting for this season. So thank you to our Australian presenters for getting up so early, so many times this fall to be with us. I will have all the resources I put in the chat, so just reach out to me if you missed something. Any farmers and researchers on here who have an extra question and aren't on the WhatsApp, you can email me and I'll put you in touch with Peter and Cassie and Brett. But otherwise, yes, thanks everybody so much.
Yep, and don't forget your questions to Newms as well, because he's got lots of knowledge too that we don't have. Okay, and also conversely, don't forget you've got people like Eric and Judd and Andrew from the manufacturers who can also give us some good input. So please put your questions out to them. The end game is still profitable farmers, and that's what everybody here wants to see. So give it a try. Thanks for your time, guys.
Thanks, everyone.
Thanks, everyone.